When we talk about distance, that's the length of a segment between 2 points. So I can take any 2 points anywhere in space and find the distance between them. Now, distance is always positive. Okay, and that's really important. Think about it this way. If you walk a mile forward, so in a positive direction, or if you walk a mile backwards in a negative, like you walk backwards a mile, haven't you still walked a mile? Yeah, I mean, you still walked a mile. It doesn't matter whether you went forwards or if you walked backwards, or so distance doesn't have a sign. It's just a length. I mean, it's always length. Length is always positive. Okay. The midpoint is the point exactly halfway between 2 points, so it's the same distance from each. So if I have 2 points in space, the midpoint would be exactly the same length, so right in the middle, midpoint, middle. And then a bisector is any point, line, segment, plane, or ray that intersects at a midpoint. So if I come through this point here with a line or a segment or a ray or anything, plane, that's a bisector. Bisect means to cut in half. You know, the prefix bi means two, right? So 2 parts, 2 equal parts, cut in half. To find the distance formula on a number line, so we're talking about only one axis. There's 2 ways you can do it. You can either count the spaces between, on the actual number line, or you can subtract the lesser from the greater.
And that's for the distance number?
That's for distance if you are just on a straight number line. Okay, so you can either count the spaces or you can subtract the lesser from the greater. To count the spaces, let's say we're doing from the distance between B and E. So I start at B and I say, okay, 1, 2, 3, 4, 5, 6, 7, 8. 8. Easy enough. Okay. If I'm going to subtract the lesser from the greater, actually I'll do another count and then we'll subtract on the other 2. If I want to do AC, 1, 2, 3. If I'm subtracting the lesser from the greater, I have C and F. C is -4, F is 5. 5 is greater, yes? We all agree? 5 better? Okay. So I'm going to do 5 minus -4. And whenever you subtract a negative, it's happy man, so it's positive. So that's 9. Sorry, that's 9. If I want to find F and B, F is still 5, and B is -6. It's going to do 5 minus -6, and if you don't like the happy man, you can make a big giant plus sign. 5 plus 6 is 11. If you get a negative answer on these, then either you did things in the wrong order or there's some other mistake, because distance is always positive. So just double check yourself. Now if I put these in the wrong order and I wrote -6 minus 5, I would have gotten -11. It's the same length, but I have to take the negative off. Does that make sense? So you can just double check yourself that way.
If F as a positive 5, wouldn't that be, wouldn't just like take the 6 and 5 subtract from it? Like,
yeah, well I did 5 minus -6.
okay, because it's already a negative.
Because it's already a -6. So the minus the negative makes it the positive. So we have both x and y values. instead of just on a number line, there's a distance formula. X1 minus x2 squared.
That says for like graphs, right?
Hmm?
That's what you use that for a graph, right?
Yeah, well, this is how we find the distance. If I have 2 points like here and here, I can find the distance between those using this formula. Okay, so it's x1 minus x2 squared plus y1 minus y2 squared, and then you take the square root of the whole thing. So what we're going to do is label so one point is x1, y1, and then the other is x2, y2. Excuse me. It does not matter which is which. So this can be x1, y1, or this can be x1, y1. What you cannot do is put a 1 and a 2 in the same parentheses. So I can't say x1, y2. Okay? So they both have to be 1s or they both have to be 2s. Okay? I usually just go in order, but that's just me. Then I take the formula, and actually, I did not put enough space on here, did I? Okay, we'll figure it out. Step 2 is you're going to plug in the numbers for x1 and x2 into the formula. Okay. x1 is -4 minus x2, which is 5. I guess I don't need that parenthesis. Squared plus y1, which is -6, minus y2, which is -1. I have -9 squared plus, okay, well, a negative of a negative became a positive, right? Mm-hmm. So it's -6 plus 1, so that's -5 squared. Okay. I'm keeping them in a parenthesis on purpose. And the reason I'm keeping them in the parenthesis on purpose is because -9 squared and -9 in a parenthesis squared are two different things. This is -81. This is +81. Okay, so you want to keep those parentheses regardless of whether you have a positive or negative number inside, just until you've done the squaring, so that you don't accidentally do this. It's really important. Okay. I'm going to move that up here. -9 squared is 81. 5 squared is 25. 81 plus 25 is 106.
And you keep the radical.
Yep, and you can keep the radical. I'm fine with that. So the distance between these 2 points is the square root of 106, whatever that is. Until you get comfortable and have the formula, you know, well in hand, I recommend always just rewrite it. just until you're comfortable with it. And until you're comfortable with it, I recommend always labeling these x1, y1, x2, y2, just to keep it straight. Okay, so I have x1 is -5, x2 is 8, y1 is 6, minus y2, which is -4, so I have another minus a negative there. So we have more space, so I'll take it a little further. -5 and -18 is -13. 6 minus -4 becomes 6 plus 4. So -13 squared plus 10 squared. 169 plus 100. So 269. x1, y1, and x2, y2, right? So I have 0 minus 3 and 0 minus -4, which gives me -3 squared plus 4 squared, which gives me 9 plus 16, which gives me the square root of 25, which is 5. Yeah, if you can see it. If not, you can still do it the traditional way. Yes, Sadia?
Oh, the answer was 25.
Square root of 25.
So you got to find the square root of the final.
If it's like a perfect square. So actually, why don't we take a second and do that? I like this color for right now. Okay, so 1 squared is 1, 2 squared is 4, 3 squared is 9. You guys get where I'm going with this?
Mm-hmm.
I don't need to record that. We can also find the coordinate of the middle, that midpoint. So this is the point in the middle. And the midpoint formula is a little strange. You have that x1, x2 thing again, except you're adding them instead of subtracting them. And then you're dividing them by 2, and it's in parentheses with a comma between it. The reason it's in parentheses with a comma between it is because you're finding a point. So you're finding an x, and you're finding a y. Make sense at all? Okay. You divide by 2 because that's how you figure out where half is. Halfway between the two x's, and you divide it by 2. So we do x1, y1, x2, y2 again. Got the midpoint. Okay, so I plug in x1 is -6, x2 is 1, y1 is, oops, that's not what I meant to do. Y1 is 3, y2 is 0. I get -5 divided by 2, and I get 3 divided by 2, and they don't divide evenly, so leave it just like that. Oh. Did you have a question? Okay. Alright, so we're going to do this one, x1, y1, x2, y2. So the midpoint is x1 plus x2, oops, x2 is not 2, it's 4, divided by 2, y1 plus y2 divided by 2. 5 plus negative 4 is 1. 12 plus 8 is 20. Now this one actually does divide, so 1/2 and 10. Okay. What we can do is if we have the two ends, we can find the middle. And if we have the middle and one end, we can find the other end. So if you have any two of the 3 points, the ends in the middle, you can find the missing point. Okay. What you can't do is have the middle and then find both ends if you only have the middle, because who knows where the both ends are. They could be anywhere. So if you have one end in the middle, you can find the other end, and that's what we're going to do here. So J, that should be an if, not an is. K is a midpoint. Okay, so K is the midpoint. And L is an end, and we're trying to find J. J is the other end. So this picture would be J, K, L, and we don't know J. We have our midpoint formula that tells us we add the two x's and divide by 2, and we add the two y's and divide by 2, and we found the middle. What I have is the middle and one end. So I'm missing one of these x's and one of these y's. What we do is we plug in what we have. The midpoint is -1, 2. We can call this x1, y1. And if we do that, I have 3 plus x2 divided by 2. And I have -5 plus y2 divided by 2. Now I have to figure out how to find these missing x's and y's. Well, this expression right here is what will give us -1. If we had the x and we divide it by 2, we get -1. And this expression right here is what will give us 2. You guys with me so far?
If that's the midpoint, why can't you plug that in?
Because it's the middle. If we plug this point in, it's already the middle. Yeah. So it's already the middle. So if we plugged it in, we'd actually find the middle of between the middle and the end. Yeah. So what we do though is we can use this and this. Oh, let me do it in blue so it tracks well.
Okay.
This right here gives us -1. So we set it equal to -1. Because if we had, just 1 second. If I had my two endpoints, right? And I knew what they were, just hypothetically, say 5 and -7. And I divide it by 2. That gives me -2 divided by 2, which gives me -1. Now these, I don't know, that's not 5 and -7, but whatever number this is, when I add these together and divide by 2, I'm going to get -1. Yes. Yeah. So to find that, we're going to take this part and set it equal to -1.
Okay, wait, so you just said it equal to 1, right?
Yeah.
Does it?
Then we solve it.
Multiply by 2, right?
So 3 plus x2 is equal to negative 2. And then I subtract 3. So x2 would be negative 5. Okay.
Because you have to get rid of the fractions and you multiply everything by 2.
Yeah.
Or,
Yeah, to get rid of that. To get rid of the divide by 2, we multiply by 2.
But where did you multiply by 2 at?
Here. Times 2, times 2.
Oh, you didn't do it up top.
These
Okay,
cancel.
sorry, got it.
Yeah,
and
those.
you do the same thing for,
And we'll do the same thing with the y, except instead of setting it equal to negative 1, we set it equal to 2. Multiply by 2. Those 2's will cancel. So I get negative 5 plus y2 equals 4. Add 5 to both sides. And y2 is equal to 9. This is my missing endpoint. Yeah, so basically, essentially, what you're going to be doing is you're going to be taking that midpoint point,
you plugging it all in.
you're going to be multiplying it times 2, and then you'll be adding or subtracting the endpoint. Is essentially what's happening. So when we do this, that's the process, right? I multiplied it by 2, that's the midpoint times 2, and then I add or subtract the other end. Here, I'll show you another one. Missing endpoint if P is the midpoint. So I'm going to put a big M on top of the P's so I know that that's the midpoint. So I don't get lost. Okay. E is my endpoint. So this is x1, y1. So I can set this up x1, sorry, m equals x1 plus x2 over 2, right? And y1 plus y2 over 2. So m is negative 5, 10. x1 is negative 8. I don't know x2. y1 is 6. I don't know y2. So I set this equal to negative 5. And I set this equal to 10. Yeah.
Okay, so for the other one, did you solve all of it, or was it just?
Yeah, no, I solved all of it. Here's x,
Oh, okay.
and here's y.
Because I went on and I plugged in all that stuff, and then I 1 and 2.
Yeah. Oh, you don't have to go back to find the midpoint because we already
Okay.
knew it.
Okay.
Okay. I'm going to multiply both sides by 2. And I'm out of room, so I'm just going to do this. And I get negative 8 plus x2 is equal to negative 10. Add 8 to both sides. And x2 is equal to negative 2. And then when I do the other one, I have 6 plus y2 divided by 2, and I set that equal to 10. Multiply both of these by 2, and I get 6 plus y2 is equal to 20. Subtract 6, and I get y2 is equal to 14. This is my other end. What you're going to do if you're going to do it non-algebraically is you're going to take your midpoint. This is the midpoint. You're going to multiply it by 2, and you're going to subtract the other point from it. When I multiply the midpoint by 2, I get negative 2, 6. Minus 5, 6. Negative 2 minus 5. this becomes, if I distribute that negative, right? -5 and -6. You have to be careful to distribute the negative if you're doing this. 2 minus 5 is -7. 6 minus 6 is 0.
But when you're gonna subtract them, you have to
Distribute.
plug in the
So-
negative into them.
Yeah, you have to bring the negative in. So if this was already negative, you would distribute the negative and it would become positive, but because it was positive, it becomes negative. Okay? So if you're going to do it this way, you have to be careful with your signs. You have to be sure to distribute the 2 in and multiply them both by 2, and then you have to be sure to distribute the negative in so that you're subtracting properly. Okay? And then you get your other end.